Hi guys, today I talk about index reversible transformation. It is similar to Brush-Willis transformation, but it has several advantages compared to Brush-Willis transformation. For example, with this transformation we can add the words, we can delete the words, so there are some advantages that make it better than Brush-Willis transformation. So let's talk about it. And the string today we are going to transform is this string, this abracadabra, and the first step is just the same as we do in Brush-Willis transformation. That is, we just do the normal rotation. So first we just write the string, then move this to the last, it goes here and everything comes one step front. Again, move this to the last and everything comes to the front again. So similarly we move this B to the last, so this comes here, it becomes end of the string, then R, A, C, A, D, A, B, R, A, and A and B. And similarly this goes to the last and it comes here, so it becomes R, A, C, A, and D, A, V, R, A, V, and end of the string. So similarly we can do the rotation just like we saw in Brush-Willis transformation. So we can continue with the transformation. Actually, I'm not going to do all the transformation because it is going to be really long. So what I will do is what we do is, like, we get all these rotations, there will be lots of rotations. Then at the next step, what we do after the rotation is we sort the rotations. And the important thing here we do is we don't sort based on the first row, which is this first row. Instead we sort based on the last row, but that in prefix order. So we basically sort this row in prefix order. That is, for example, if it is A and here is also A, then we look at R, and here there is N of the string, so this guy will go up. So we look at the prefix order while doing the sorting and we do the sort. So this is what we get after the sorting. So here I'm not writing all the intermediate columns, so we only focus on the first column and the last column. And if you notice, then we have sorted based on the last column but in prefix order. For example, here the last column has the same character, so we look at the next prefix character and based on that we do the sorting. So same is here. For example, these are the same, so we look at the next prefix character, and in this way we do do the sorting, and we have this final state after we do the sorting. And what's interesting about this is, if you see at the original string, that is abracadabra, here you can see one word. So basically this is the one word, second word, and the third word. So these acts as the splitter between the words. So here we see there are 3 words, and if you see this rotation, the rotation column, if you see the first column, then you'll notice like these 3 letters are special. Why they are special is, so this means it is the beginning character for the first word, which is this abra, av. Then this is the second word, beginning character of the second word, and this is the third character. So if you see, R is this R and D is this D. So what we see is IRT maintains the order of the word. So the corresponding column is also true. So this is the end of the string for the first word, this is the end of the string for the second, and this is for the third word. So I'm again going to repeat because something happened to the video. So this is the final result of the rotation, and if you see here, then if you see the first column, then you can see there are 3 characters. What is the speciality about this character is the first letter corresponds to the first word. So if you see the original string, then there are 3 words, that is AV, RAC and DABRA. And this A corresponds to this R corresponds to this, and this D corresponds to this D. So what we see is IRT preserves the sequence of the string, and if you see the corresponding last column, then this is the end of the string of the first word, this for the second, and this for the third word. Now we see the rotation, and we have the first and the last column. Now based on the first and the last column, we try to recreate the whole string, but we can also recreate, in this session, let's try to recreate a word. For example, if you see the original string, then there are 3 words. Let's try to recreate the second word, that is RACA. So to go to the second word, we have to go to the second letter of the first row, because as we said, the first character denotes the starting of the first word, second character the second word, and third the third word. So we go to the R and we write R, and if you see, this is the first R. Let me change the marker. So if you see, this is the first R. So we go to the last column, which has the first R, and this is this, and corresponding to this R is A. So we write A, and if you see, this is the first, second, third A. So we go to the third A in the last column, and then that is first, second, no, this is first, second, third, fourth A. So we should go to the fourth A here, and this is the fourth A. So we go to this fourth A, and the corresponding character is the C. So we write C, and if you see, this is the first C. So we go to the fourth C. And this is the first C. Yeah. And this is the first C, and if you see, the corresponding character is the A. So we get RACA, and if you see, this is the second A, and we go to the second A, and this is the second A, and the corresponding character is the end of the string, and we end the algorithm means, so we get the second word. See the recreation of the second word, that is RACA. So there is one property of IRT transformation is when you delete, then still the order is maintained. So for example, if you delete, then delete is also the same way as you reconstruct the word. So for example, if you want to delete the second word, then how you do is you proceed with the second letter as we do in the transform this word creation. So we first delete R, so R goes away, and this so this A goes away, this A goes away, this C goes away, and this end of the string goes away. So if they go away, then what you can notice is still in the first column is still valid in terms of the sequence. So when we delete these red letters, then what remains is A, D, B and other character, and A still is the first word, and D will be the second word after the deletion. So the order of the word is maintained, and sequence, hence the sequence is also maintained. So after the deletion, this is the state we are in. So if you see, then we delete all the red thing. So if you delete the R, then the corresponding letter in the last column also goes away. If you delete this, then this also goes away. You delete this, this goes away, delete this goes away, delete this, and this goes away. So if you remove all the deleted thing, then we come to this state. Now say we want to insert the same word, that is RACA. So we want to insert this word again. So how to proceed? And we want to insert in the same place, because we deleted from abracadabra, we deleted RACA, so we have only AV and DABRA. So here we want to insert. So this is the whole word and this is the deleted word, and here we want to insert. So we are inserting RACA as the second word. So we begin with the second position. So this is the first, as we know, this denotes the first and this denotes the second. So here we are inserting the second, so we insert here, and what we insert is the R. So we insert R here, and if you see, this is the first R. So we have to put so you put R, so in the last column also you have to put the R as a first R. So if you see, the last column is the sorted column, so if you see, then R is here and you have to put the first R. You can't change this position, but you can put R here. So here comes the R, then we have to insert A, this A. So we insert A here because this is the position where we insert A, and if you see, this is the first, second and third A. So in the last column also you insert the third A. So if you see in the last column, then there is first A here, second A here, and third A here. So you insert just above this. So this is your third A, and your third A is now fourth A. And corresponding to this, you insert the next word, that is C. So you put C here, and it is the first C. So you have to insert C here also. There is no C, so you have to insert C between B and D. So you insert C here. Now corresponding to this position, you should insert another letter, that is A. You insert A here. And if you see, this is first, second A. So you have to insert second A, and if you see, there is first A, second A here. So you just insert A above it. And corresponding to this A, you should insert the next letter, that is the N character. So you insert N of the string here, and yeah, we end algorithm. So we get the new transformation which contain the first column and the second column with the inserted word. So this is how we insert the word in the transformation. So this is equivalent to inserting the word during the compression. So this is the one advantage of IRT. IRT allows deletion and insertion without decompression.